So in our code we have a virtual function, which is the display permissions function in the user class. What it does is it displays the permissions of the user, and it lists the permissions as creating playlists, listening to songs, and rating songs, which is what the user is capable of doing. Then in the artist and administrator child classes we have that same overridden display permissions function. And what it then does is it calls the user display permissions function, as each of the child classes have the same permissions as the parent class, as well as the additional permission per each child class. So for example, for the artist we have the permission to publish songs, and in the administrator class we also have the permission to delete users, and that would be the polymorphic call to a virtual function. As for pointers, the playlist class contains a vector of pointers to song objects. This way, if a song gets updated outside of that playlist, all the changes will be reflected inside of that playlist vector. The way we have achieved that is by passing in addresses to song objects as opposed to passing in actual song objects. So that way there is a pointer to them instead of the actual object being copied into the vector. So as you can see, when you add a song, instead of passing in the actual song object, you're passing in an address, so basically a pointer to that song, and then that gets added into the playlist vector. And the same story when you're removing a song, you pass in the address to that song object. It then gets compared to all of the elements inside of the playlist, and if that song is found, the pointer from that song will then be deleted, and the entire song itself, the actual song object itself, will not be removed. Rather, just the song will be removed from the playlist. The pointer to the song will be removed from the playlist. For the overloaded assignment operators, we have two implementations of overloaded assignment operators. One for the user class, which then of course gets passed down into the child classes, the administrator, and the artist class as well. And you can compare them, see if they're equal or not equal, and see if one's greater than or equal to or less than. And this is done by alphabetic name. So as you can see, for comparing two users, it checks their username, and we are going under the assumption that two users can't have the same username. So if their usernames match, that means they must be the same user. Same for the not equals to, we just compare the already used equals operator and return the inverse of it. To compare whether one user is greater than or equal to, we just check by the name, check alphabetically to see, so you can sort users alphabetically. And for the song class we took a different approach. Sorting all songs alphabetically probably usually isn't the most useful feature, so instead, as you can see, to check if one's greater than or equal to, we compare the ratings of the song, so you can sort them by ratings. To compare the songs if they are the same, it checks both the name and the artist name, because two artists may have a song with the same name, but chances are unlikely that the same artist will put out a song with the same title twice. So it checks both the name and the artist name. For our custom destructor, we have in the user class a function to clear out the playlist vector, so it basically deletes all of the playlist data and all the pointers to the songs without actually removing the songs. We then also have a custom delete user function that decrements the number of users. This is so that in case a copied user object calls the destructor without calling the constructor, so that the number of users does not constantly decrease because of the copies without actually increasing because the constructor was never called. So that way you would have negative numbers for the number of users and it wouldn't actually match to the number of users there. So instead there's a custom function to delete the user, which then calls that user's destructors and decrements the number of users. The function also checks if the user that's being deleted is the user that is calling the function, so it's checking if it's deleting itself. If it's not deleting itself, it will say that the user does not have permission to delete other users. And then there's an overridden version of that function in the administrator where it will actually allow you to delete other users. It won't check to see if it's the same user that called it. The last part of the program we have is the main.cpp, where all of the functions are tested. As you can see, everything is commented to explain what it's doing. And if you compile it, as you can see, it'll compile just fine and return 0, so it works. And then if we compare the program and the code side by side, as you can see, first the song objects are created. That shows nothing. 4 different user objects are created, which would be 2 regular users, 1 artist, and 1 administrator. In between the creation of each user, we check the number of users, which is a static integer, and as you can see, it prints out and then it increases for every new user. So it says the number of users is 4, which is the number of users that were created. We then test the display user, which shows up for the user Rafa Volk, which is the name that was set in the constructor. We check the overridden display user for the administrator, and it shows up. It says administrator username Betsy the cow. We're still funny. The same thing goes with the artist. When we do the display user, the overridden display user function on the artist, it comes up as artist username SebiB, artist number of song 0. We then test the association relationship when we publish the 2 song objects we created earlier through the artist, and then display the user, which is the artist, and list his songs. As you can see, they all show up now with the new artist name, and it says artist SebiB. And then if we display details from one of the song objects that was published through the artist, it'll say artist SebiB. So that song is now associated with the artist. Then if we test the play song function through the user one, as we can see, it will display Rafa Volk is now playing SebiB the Rude Sandstorm. Funny joke, I know. We can also test the rate song function through that user. If user 1 rates the song S1 4.3, will show up Rafa Volk rated the Rude Sandstorm 4.3 out of 5, and all of those ratings will be stored in a vector, and then the average will be calculated to get the ratings. So now if we display detailed for that song, it will show the rating will show up as rated 4.3 out of 5 by 1 person. Next we create a playlist object, and then to that playlist we add pointers to songs S1 and S2. And if we then display that playlist, as you can see, the playlist will come up with the name given in the constructor, and then the 2 songs will show up. Next is another test of the rating song function, where that song S2, SebiB Lala, is rated 3.9 out of 5, and this is done to the song outside of the playlist. And if we see later, it should update within the playlist, because the playlist basically just has a pointer to that object, so even though it's done to the object outside the playlist, it should still show up in the playlist. So next, as we can see, we can add the playlist to the user, and it'll show up Rafa Volk's playlist YZ 2020. Next we test the virtual functions. As you can see, if we just test the function for a regular user, it'll show up Rafa Volk has the following permissions: creating playlists, listening to songs, rating songs. Then if we do the same for the artist, it will show up as SebiB has the following permissions: creating playlists, listening to songs, rating songs, publishing songs. So it's the same as the user, except with the addition of published songs. Same thing with the administrator, except that will have an extra deleting users. Next we test the overloaded operators. So as you can see, we have 2 users, Rafa Volk and SebiB, and it will show up that they are not the same user because they don't have the same username. Then if we test it on the same user, it will show up Rafa Volk and Rafa Volk are the same. Again, we're going under the assumption that 2 users cannot have the same username. Next we check the greater than operators, and as we can see, it says user SebiB is further in the alphabet than Rafa Volk, which is true because S is further in the alphabet than R. At the same time, we're also testing the cout operator, which is also overloaded. As you can see in the code, all we do to display the users is just to cout the actual object, and it will show up the user information. Lastly, we test the overloaded operators on song objects, and if you can see, it will show up as SebiB the Rude Sandstorm is rated higher than La La La, which is what we expected because Druid Sandstorm was rated 4.3 out of 5 and La La was only rated 3.9 out of 5. So that's the results we expected. Next, we test playlist sorting. Playlists can be sorted by different parameters. Two of them are the song names alphabetically, as well as by ratings. So if we create 4 new test song objects and then add them to a playlist, afterwards we rate them, and as you can see within that playlist, all of the ratings do show up, so it gets updated inside of the playlist, even though we rated them outside of it, just because the playlist actually contains pointers to the song objects. So if we try to sort the playlist by addresses, that is not something you can sort by, so it should show up an error unknown sort type address. Next, if we test sorting playlists by ratings in descending order, you'll see that the playlist will be sorted by ratings. So as you can see, 4.6, 4.3, 3.9, 2.3, 1.9, and 0. Then we can also do the same thing except in ascending order, and it'll be the same except flipped. We can also sort by name. So this is by name in descending order. As you can see, it does in fact sort them alphabetically in descending order. L, D, D, C, B, A. And then in ascending order is the same, except reversed. We removed this song from the playlist, and if we display the playlist again, it will now no longer show up in the playlist. Next, we check the custom destructor function. Once again, we see that there are 4 users using the get number of users. First, if we try to let the artist delete a different user, it will give an error. It'll say SebBB does not have permission to delete other users. This is just a test to make sure that only administrators can delete other users. However, if that artist user tries to delete himself, it will show up that the user has been destroyed through the destructor, and then the number of users will go down by 1.